Dear students, today topic is JK flip-flop. It is an alternate way of eliminating the forbidden condition in the SR flip-flop, right? Here, the inputs JK behaves like inputs of SR flip-flop to set and reset the flip-flop. When both the inputs J and K are equal to 1, then the flip-flop switches to complement state, right? Whereas in SR flip-flop, the both S and R is equal to 1. The next state is a forbidden state, right? So that can be eliminated with this JK flip-flop. Here we are given both J and K inputs are equal to 1. Then the flip-flop switches to toggle state or complement state. Let's see how it will produce the complement state at the input of 1-1 combination, right? So this is the circuit diagram of JK flip-flop. This circuit also similar to SR flip-flop, that is two NAND gates, that is 4 NAND gates is used. And that only difference is the JK flip-flop uses the two AND gate cross coupled connection. So these two AND gates, these two pair having one cross coupled conditions, and these two gates are cross coupled connections, right? So totally 4 NAND gate cross coupled connections, right? Let's see the operation of this flip-flop. So initially, as usual, when the clock signal is 0, which means the one of the input of these two NAND gate is 0, so obviously the output of this NAND gate is 1. So this 1 is nothing but input of this SR NAND latch. So we know the SR NAND latch truth table. 1-1 condition provide the no change, which means the past value, right? But we want changes in our next state. So the clock signals is always high because of that one level triggering. Okay, let's consider if clock signal is 1 for the all condition of J and K 0, 0, 0, 1, 1, 0 and 1, 1. In all these combinations, clock signal is high. For first pattern is 0, 0. In these two NAND gates having the 3 inputs. So one input is clock signal, we know that value is always high. And second input is J and K. So the J and K inputs are maybe any one of these 4 possibilities, right? What about the third input? So the third input nothing but cross coupled connection to each other, which means which is the output of the next state. This is Qn, this is Qn plus 1, the Qn bar complement, right? So these two NAND gates having totally 3 inputs. Let's consider the first gate 0, 0. So now this input is 0 and this input is 0. One input of the NAND gate 0 means then output also 1, right? So both output having 1. So 1-1 combination is in SR NAND latch provide the next state is the same Qn, that is no change. So we can write that in a JK flip-flop input is 0, 0 condition. Our next state will be the previous state, which means no change condition Qn, right? Let's consider this second input 0 and 1. J is equal to 0, K equal to 1, right? So second condition is J0, K equal to 1. Now in this NAND gate, one of the input 0, so we don't consider about the third input, which may be 0 or 1, not an issue because one input is 0, so obviously the output of the gate is 1, right? But here in this gate, our K value is 1, right? Clock signal is 1. So here definitely we should know the third input because it may be 0 or 1. We don't know about whether it's a 0 or 1. So for that I'm going to consider the 2 cases of past output. So first case is I'm assuming that past output is 0. If Q is 0 means Q bar is 1. Now the third input of this gate is what? Which is connected to this here. So Qn value. So third input is 0. Now the output of NAND gate is 1, 1, 0 is input. So 1, 1, 0 combination provide the output is 1, right? Again here the output is 1. Here the output is 1. So which is nothing but input of this SR NAND latch. The next state of this SR NAND latch is no change condition. So no change means past output will be the present output. So past output is 0. So for present output is also 0. If Q0 means Q bar 1. So J is equal to 0 and K equal to 1 input condition. If we assuming our past output is 0 means the next state also as the same as of past output. This is one case, but if the input 0 and 1 condition, the past output is possible to consider 1 also. Previously we considered Q0, now the past output is, let's consider Q equal to 1. The Q equal to 1 means Q bar equal to 0. So in this condition, what will be the next state for this combination of 0 and 1, right? So anyhow, in this case output is 1 because J input is 0. Right, we don't want the third input. It may be 0 or 1, not a problem. Because of the 0, the output is 1. But in the case of second gate, the K1, but we don't know this third input value. Right, now the third input is Qn value. So Qn is, we are assuming 1. So here 1. So the three inputs are now 1, 1, 1, which is given to this NAND gate. So the NAND gate output become 0. So now the SR NAND latch input is 1, 0. So the NAND SR latch input 1, 0 provide the next state is what? 0 state, right? Reset state, which is mean Q equal to 0, Q bar equal to 1. This is the next state for the input of J is equal to 0 and K equal to 1 when the past output is 1. Right? So in these two cases, the past output is 0 or 1 is not a problem. When we apply the input is J0 and K equal to 1, then the next state will be the 0. Right? Is it clear? In both the cases of past output is 0 or 1, our next state will be the 0, reset state, with respect to the input condition 0 and 1, right? So we can write in a truth table 0, 1 combination of input produces the next state will be the reset state. Okay. Next, let's see the next state for the input pattern 1 and 0. Right? 1 and 0. So J input is 1. And K input is 0. So here in this gate no problem about no problem on the third input because one of the input is 0. So obviously the output of that gate is 1. But in this NAND gate, one input is 1 and clock input is 1. But we don't know about the third input. So we should know the value of third input also. So for that again we are considering the two cases of the input J is equal to 1, K equal to 0. For the past output Q may be 0. If Q 0 means Q bar equal to 1. This is first case. So in this case, let's find the next state of that particular input. J is equal to 1, K equal to 0. Right? So let's consider J is equal to 1. Then Q equal to 0. Then what about the third input? So third input is Qn bar. So Qn 0 means Qn bar 1. So here 1. So now the input of the 3 input of NAND gate is 1, 1, 1. So which will produce the output is 0. Now the SR NAND latch input is 0, 1. So 0, 1 combinations provide the next state of the SR NAND latch is 1. Right? So the next state will be the 1. If Q1 means Q bar equal to 0. This is first case. But is there possibilities of past state or past output maybe 1 also. So in that case also we are going to check for the input of J1 K0. Then past output is, let's consider 1. Q1 means Q bar 0. Right? Now check with that circuit. J is equal to 1, K equal to 0. So because of that 0, output is 1. And here 1, and our past output is Qn equal to 1, right? So Qn1 means Qn bar is 0. So that 0 is connected to the third input of this NAND gate. So 1 0 1 input will provide the output of NAND gate is 1. So if both inputs are 1 for the SR NAND latch, so SR NAND latch truth table 1 1 combinations provide the no change condition, which means passed output. So here passed output is 1. So that will be the next output also, because of the SR NAND latch truth table 1 1 conditions produces the no change, that is Qn value. So whatever Qn passed we are used to, that will be the next state output at the condition of 1 1 in a SR NAND latch. But here we are given the input is J is equal to 1 and K equal to 0, right? So J is equal to 1, K equal to 0. The past output may be 0 or 1. It's not a problem, but our next state output will be the set state with respect to the input pattern of J is equal to 1 and K equal to 0. So we can write in a truth table for the input values J is equal to 1 and K equal to 0. The next state will be the set state. So here 1 0 equal to set state. Okay, and last condition 1 1. So here also in the same manner we are going to check if both inputs are 1. So here in both the cases we definitely should know the values of third input, right? So let's consider the same. Initially Q equal to 0. So Q equal to 0 means Q bar 1. So Q bar that 0 is connected to here and this 1 is connected to here. Now here 3 inputs 1. So output is 0, right? Now one input is 0 because let's assume Qn equal to 0, right? So Qn 0 means this input is 0. So one of the input 0, the output will be 1. So 0 1 combination in the SR NAND latch provide the set state, right? So our fourth condition is J1 K1. Initially we assume past output is 0. So in that condition our next state will be the 1, right? This is one case. Let's assume our past output is Q equal to 1. So Q1 means Q bar 0. So here both inputs are 1 1. So Q bar is 0, right? 0 1 1 provide the output is 1. Here Qn is 1. So 3 inputs are 1. So 0. So 1 0 input of the NAND SR latch provide the reset state, right? So our next state will be the reset state. So 0 means Q bar 1. In that both cases, if we are considered that past output is 0 or 1s, our next output will be the complement of the past output. Look at here. Our past output is 0, then present output is 1, just complement. In that case also our past output we consider as 1. So the next output is 0. So complement of the past output for the given input of J is equal to 1, K equal to 1. So we can write in a truth table 1 1 input pair produces the output is complement of the past output. So Qn is past output, so Qn bar. So now this is the truth table of the JK flip-flop. So 0 0 state produces the no change. 0 1 condition produces the reset state. 1 0 condition produces the set state. 1 1 condition produces the complement states.